Next key. So in this video we are going to discuss about gray to binary code. So here, how before going into the design, the how to from convert gray to binary. So just look what is a conversion process in theoretical manner. So for example, if you consider like 001, if you can take any binary bit, but here I consider 4-bit 4-bit binary code. So for converting purpose, you can take any number of bit, but for our example, in this code I designed 4-bit gray code to binary converter. So for 4-bit, this is our LSB bit, and this is our MSB bit, last bit. So it is our MSB bit. So what you are going to do? So first MSB bit is going, it is gray, and it is our binary code. So in theoretical, how we are going to do? So first MSB bit is going to be same. So next this 0 is going to be XOR, means next bit is going to XOR with the result what you are getting in this step. So is going to be the next step. So 0 XOR 1 is nothing but 1. So again 0 XOR with 1 is nothing but 1. So 1 XOR is 1 is nothing but 0. So our binary code is like this. So what you are going to do for gray code? See, G3 means MSB bit and G0 means LSB bit. So it is our gray code. So B3, B2 our binary code. So how you are going to get? So B3 is directly by getting the MSB. So you can directly get the G3. So how you are getting B2? By XORing these two. B3 XOR with G2. So again how you are going to get G1? So this G1 is going to be XOR with B1. So G1 XOR with B2. So G0 XOR with B1 we get B0. Like that we are going to get our binary bits. So just write this code in design code. So how you are going to write? So first module and star and followed by module name. So whatever input port, so there are the 4-bit gray code in, so there is a 4 bits for gray code. So output is like 4 bits for binary. Next what you are going to do? So see, the MSB bit is going to be same as the MSB bit for binary one. So that's why simply is buffer. So what is the functionality of buffer? So functionality of the buffer means if you give input as A means the output is also same as the input. So it is the buffer. So you know about the primitives in Verilog. So I already discussed about what are the primitives, how we are going to use. So there is a primitive. So how you are write means you have to write the primitives. Inbuilt gates. It is already inbuilt in our Verilog design. So primitives followed by instance name and followed by out, inside the braces you are writing for outputs followed by inputs. So if it has a single input means you can mention single input. Otherwise if multiple input means you can represent it multiple inputs. So like this you can write the buff, and the B1 is our instance name, and see our output is B of 3. What is our input? Directly our G of 3 is going to be assigned to the B of 3. So that's why simply write B of 3 comma means output followed by input. So next how we are going to get our B2 means B of 2. How we are going to get XOR operation of B of 3 plus G of 2. See, G of 2 comma B of 3. So these are our inputs. So 1 XOR 0 is equal to 1 or 0 XOR 1 is equal to 1. So no change about this. So I can write reverse order also. So XOR X2 of how we are getting our B1. So G1 XOR with B2. See, you can write the same one. G1 XOR with B2. We simply represent here by using this primitive language. So primitive in Verilog language. So and with end module. So it is our test bench code. So our syntax is same as for every code. So it's module followed by module name, and our what are the inputs we can make it as a reg data type. So what are the outputs we make it as a white data type. So why you use reg for the input means there is whenever you are going to use the initial and always block. So if you use these blocks, what are the variables inside the you are using? What are the variables you are going to use inside these blocks? So it should be a reg data type. So see, G is going to be used in the initial block. That's why you make it as a reg data type. So otherwise you can make input ports as a white data type also. So no bother about that. So it is the reason because when you are going to use the initial block or always block, what are the variables inside you are going to use, that should be a reg data type. So next we have to connect the design code with test bench code. How we are going to connect? By instance the design code in the test bench code. How we are going to instance? So write simply the design code module name. So it is the design code module name. So followed by instance name. DUT means design under test. You can use any name also. So no need to be DUT only. So followed by port list. So you can connect the ports in your design code and test bench code by using the port list by order. There is a by name also. It already have separate video. If you don't watch means go through that, so then you can understand about the port connections. So next they in initial begin. So they are the input combinations. So whatever the values you are going to give to the input, and cross check your output according to your waveform. So I can give the 4-bit values here, different G values, and give some delay. Slash means it is like delay, so you can give some delay, and slash finish is nothing but used to stop the simulation. First stop the simulation, we are going to use the dollar finish symbol. So begin is end with end. So these 4 lines are going to use to generate the waveform in EDA playground. If you are doing this code in any Vivado tool or any other tool, RTL tool, so no need to use these 4 lines. So you have to go through that. So if you use EDA playground, if you want to generate the waveform, so you can use these 4 lines. So end with end model. So our waveform is like this. So see here, whatever the line shows the values here. So 5 6. So what is the 5 in binary in gray code? How you are going to represent means 0 1 0 1. So how you are going to convert into the binary 0? So 1 XOR is 0, nothing but 1. So 0 XOR with 1 is nothing but 1. 1 XOR 1 is equal to 9. So its value is going to be 6. So see, its value is 6. So like that you can cross check. You can give different inputs and cross check whether your output is going to be correct or not. So it is the process how you are going to convert from gray code to binary code. If you have any doubts, you can comment on it. So no need to hesitate about any single doubt also. Thanks for watching, and then bye.